In this lesson, our objective is to find the area of trapezoids, rhombuses, and kites. The trapezoid is a quadrilateral with exactly one pair of parallel sides that are called bases. The non-parallel sides are called the legs of the trapezoid. And then there's the altitude or the height of a trapezoid is a perpendicular segment from one base to the line containing the other base. So here in this diagram, let's label it H is the height. And then you have the non-parallel sides. Each of those are legs. And then we have two bases, the two parallel sides. Each of those are bases. So that brings us to the area of a trapezoid. The formula for the area of a trapezoid is going to be half the product of the height, the sum of the bases. So you have to be able to identify which sides are the bases in order to know what the height is going to be the distance between the bases. In this formula here, it looks like it left the height off. Yeah, so half of the height times the sum of the bases. And the last theorem in this lesson is the area of a rhombus or a kite. They put these together because they have the same formula. The area of a rhombus or a kite is going to be half of the product of the lengths of its diagonals. So here you have to be able to identify what is a diagonal. A diagonal, by definition, is a segment that connects two non-consecutive vertices. So two vertices that are not beside each other. So here in this diagram of the rhombus, we have one diagonal connecting two non-consecutive vertices, and then there's a second diagonal that connects the other two non-consecutive vertices. Same thing in the kite. Going to have two non-consecutive vertices that are connected from one diagonal, and then the other diagonal is the other set of non-consecutive vertices. So once you identify what the diagonals are, you just, the length, if you know the lengths of the diagonals, multiply them together and take half. And that's going to be the area of the rhombus or the kite. So let's look at some problems. In the first problem, you're finding the area of a trapezoid. So the bases are the two parallel sides. So one base is 8 millimeters, and the other base is 14 millimeters. So we can say that this is base 1, this is base 2. So we still need to know the height, because the area of the trapezoid is going to be half of the height times the sum of the bases. So you still need the height. For this, we need to use the fact that they gave us a right angle here that's between the two bases. So if you draw this auxiliary side here that's also at a right angle, you're going to have a rectangle. And the opposite sides of a rectangle are congruent. So that means if we can take the 8, that's the top base, and then we would know that the bottom of that rectangle is also 8. So if you subtract the 8 from the 14, you're left with 6. So the other part of this right triangle, you have a right triangle over here that's a 45-45 90 right triangle. So what do you know about the 45-45, the legs of a 45-45-90 triangle? The legs are congruent. So this leg has to be congruent to that leg of the right triangle. So that tells you that that height is 6. So if you look at your formula now, you have all the parts that you need. Your 1/2 times the height is 6 times the sum of your bases, and your bases are 8 and 14 is your second base. So 1/2 of 6 is 3, and 8 plus 14 is 22. So that gives us an area of 66, and we're in millimeters squared because area is always in units squared. Problem 2, you're finding the area of a kite. Here you just need to know that your formula for the area of a kite is going to be half of the product of your diagonals. Diagonal 1 times diagonal 2. Now it doesn't matter which one of these is diagonal 1 or diagonal 2. So we'll say that diagonal 1 is the diagonal that's 4 plus 4, which is 8. And then we'll say diagonal 2 is this diagonal. So diagonal 2 is going to be the 2 plus the 8, which is 10. So if we substitute these in, we got the area, it's going to be 1/2 of diagonal 1, which is 8, times diagonal 2, which is 10. So that's going to be 40. And we're in inches, so it's inches squared. Problem 3, you're finding the area of a rhombus. Remember, rhombus and kite, same formula. The area is 1/2 the product of the diagonals. So here, these measurements that they give you on the outside are actually your diagonal measurements, because this diagonal on the inside is the same as this measurement. So diagonal 1 is 15.5 meters, and then the second measurement they give you, this diagonal, is the same as this measurement on the outside. So diagonal 2 is 8.4. So if you substitute these measurements into your formula, you get 1/2 of 15.5 times 8.4. And put that in your calculator, you're going to get 65.1, and that's meters squared for the area of the rhombus.